This framework was released last year by Apple. Actually, we can use it with Xcode 15, and we can use it from iOS 17. So actually, this is a limit. The main advantages of this framework is that it's written in Swift. So we can use it with, for example, SwiftUI, and we can use friendly function using in Swift. Under root, the SwiftData works with core data, so we can integrate it in our application if we have different stacks. Hello everyone, I'm here today to explain to you how SwiftData works and its advantages and its limitation. Okay, my name is Emilio Arvonio, as Mario said before. I am a senior iOS developer in a wonderful company called OpenReply. I know that so far you have followed various talks with great speakers, but for me, this time, it's the first time as speaker in a conference. So in my case, for example, I don't have a cool photo to show on my slides. And since I am an artist and I don't have it, I imagine it myself like this, for example. Actually, I have more than 3 fingers, and I can move my arms. And I hope that photographers can take a good photo of me. Just to be sure. Okay, let's start with SwiftData. And what is it? This framework was released last year by Apple. Actually, we can use it with Xcode 15, and we can use it from iOS 17. So actually, this is a limit for this framework, but we will see in the during the presentation how we can use with core data, for example. The main advantages of this framework is that it's written in Swift. So we can use it with, for example, SwiftUI, and we can use the friendly function using in Swift. Under root, the SwiftData works with core data, so we can integrate it in our application if we have different stacks. Okay, Apple created this framework. So actually, I think that in the near future, we will see the application based on SwiftData, SwiftUI, and Swift. Actually, I think that everyone knows that when Apple releases a new framework, the last one has some limitation, has some bug in it, and it's not stable at the moment. But we'll see how can use this framework today. First of all, I created 2 structs. I created a Pokemon struct and a stat for the Pokemon. We want to use this Pokemon and we want to save it on my SwiftData with my SwiftData framework. To do that, the first change I need to do is to move from struct to class. Because actually, if you use a struct with SwiftData, Xcode won't show an error until you run the app. So that time, there will be an error on your Xcode. And one more thing, with SwiftData, every model implements observable, identifiable, and is hasheable. So we can use our model as a state or as a binder. Okay, so we moved from stack to class, we import SwiftData, and we can add a simple macro that is model. That's it. We can use this Pokemon, and we can save it on our stack. In this case, we can save it on our iPhone on iCloud. There is one more thing. With this format, we can already use it for iCloud. So in this case, if you have the iCloud capabilities on your project, you can save it. For SwiftData, we need one more capabilities, that is background modes with the remote notification checked, because the system will send you silent notification to your application to synchronize the local data and the data on your iCloud. Okay, let's move on. We want to specify some behavior related to our property, and we can use an attribute. In our case, is a new macro attribute, where we can specify a specific behavior for our property. In our case, attribute has several parameters. For example, the options that we will see very soon. The original name that we can use it if we have a new version of the schema. So if we have an older version, and we change, for example, the name of the property, and we release a new version of the schema, we can use this parameter to match the latest version with the newest. And the modifier that is a unique hash value. Okay, let's go with the options. We can define an encryption to use on iCloud. We can save our parameter in an external storage, so we won't save this parameter in our database. For example, if we have a big data, I don't want to locate it in our database, we can save it in a different part. We can preserve the property in a persistent history when the context delays, for example, the owning model. The spotlight parameters, we can use it to index the property in our spotlight. I tried this parameter and actually it doesn't work very well, so, but there is. We can define the parameter as unique across all our models at the same time, and we can make it ephemeral. These parameters means that we won't save the parameter on our database. So we can track its changes, but we won't save it when, for example, we save the model. Okay, we define also our name as unique. But we have stats. Stats, as I said before, is another struct. And we want to specify the relationship between the Pokemon and the stats. We can use another macro called relationship. This macro has different parameters, just like attribute. For example, there is an option. In this case, relationship has only one option that is unique. So we can specify that this relationship is unique across all the database. The delete rule, the minimum and maximum count, so to specify the relationship between the two models in our case. Original name as attribute, as I said before. Yes, and inverse. This parameter is useful when, for example, in our struct we have a double relation between the two models. For example, in stat, if we have a Pokemon, we can specify which property of the stat is related to the Pokemon itself. Let's see the late rule. The first one is cascade. This means that if you delete the first model, all the model related to it will be deleted. Deny, that is a rule that prevents the deletion of a model because it contains one or more reference to the other models. No action, that is a rule that doesn't make changes to any related models. And nullify, that is actually the default value, and the related model's reference to the related model. Okay. We define our relationship too. Now, in many cases, we can have a property that we want to save. Actually, we can use another macro to specify that. And that's the transient macro. With this macro, we are specifying that battle phase, in this case, won't be saved on our SwiftData stack. Actually, we will see a difference because I talked about attribute ephemeral. They have a slight difference. I mean, attribute ephemeral actually, according to the documentation, works very well with the refresh of the UI, in particular of the SwiftUI view. I mean, if you are using a transient property and this property changes, the view won't be updated. While with ephemeral, this happens. Okay, we can have just a brief recap. To take a deep breath, we talk about model, we talk about attribute, relationship, and transient. We can now move on the second part of our presentation, and we can talk about the relationship between SwiftData and SwiftUI. Just to understand, I want to do a question to you. How many of you work on apps written completely in SwiftUI, actually? Just raise your hand. Okay. Few. So to be exhaustive, I want to show how can we use SwiftData with SwiftUI and how can we use it with UIKit. Before we can start to explain the diagram and the relationship between the element that we can use with our Swift data framework. The first one is the schema. Our model defines our schema. In our case, with Pokemon, we have already a schema. But if we want to create a complex schema, we can use a specific class to do that. Then we have our model container. This is the broker between the model context, and the persisting store. So it creates a database from a given schema. It manages the reading and writing of data to and from disk, and it also can handle iCloud sync. The last one is our model context, that we use it to fetch, create, or delete objects on our database. And we can save our change with the model context. Last but not least, we have the database. Actually, SwiftData use SQLite database. So it's not as core data. For example, core data has more database that we can use. Actually, SwiftData use only SQLite. But we can use both. And let's see how we can create a model container. It's very simple. We can just add a view modifier to our view group, for example. We define a single model, so we can pass that model to the model container. And that's it. In SwiftUI, we created, with a line of code, our model container. This is a little bit different in UIKit. So we have to define the creation of the container with a do-catch syntax. And we have to create it, for example, in a class, in a singleton, or in a manager, where everything you think is good. Just use a design pattern to manage it. And let's move to the schema. In this case, I wanted to add a new model to my schema, a trainer and gym, for example. So I use the schema class to specify the models that I will use in my application, and a version to use it in different. We will have a different version in the new release. The schema works with configurations. For example, in this case, I created 2 configurations. The first one uses the schema. With URL, we can specify the path where we want to save our database. With allows save, we can specify if this configuration permits to write the changes on the database or not. And with CloudKit database, if we are using CloudKit, we can express where we want to save the changes. Actually, with SwiftData and CloudKit, we can use private, but at the moment, we cannot use, for example, the shared container and the public container. Another configuration is in memory, so maybe we don't want to save our changes or our model, but we need them in our application. So we can specify stored in memory only, and we will use the models at the beginning of the app, and they won't be saved. And we can use this configuration with our model container. So we can create the model container. Okay, actually, we have 2 more parameters for the view modifier. They are the is autosave enabled. By default, this parameter is true. So during the life cycle of your application, every change you will do on your models, they will be saved by the model container by default. If you don't want this behavior, you can specify false for this parameter. While if you want to apply undo and redo behaviors on your application, you can put this undo enabled parameter to true. So in this case, your application will work with, for example, the shaking of the phone to undo the changes, or with the swipe with the 3 fingers to left to right. Actually, in the UIKit, we have a different approach. So we need to create our context. We need to define is autosave enabled with a different property. And we need to use the undo manager to disable or enable our undo registration. Okay, we talked about model context. If we want to use it in our SwiftUI view, simply we can recall it with the environment property wrapper, and we have our model context. In this approach, the model context works on the main actor, so it's on the main thread. We want see if we want to change something in UI, you won't be any problems. But it's a little bit different for UIKit. So in this case, we can define different contexts. For example, in the previous, that was the context related to our model container. But in UIKit, if you create a model context in a different way, you have, for example, a model context that can work in a different thread. But also, if you are using your container, you can use the main context property that is the same as the main context in the SwiftUI view examples. Okay. Now, with model context, we can do several operations. For example, we can insert our Pokemon in our database. We can delete a Pokemon. Actually, if we want to save it if we want to save our changes in a specific part of our application, we can call the method save. And we can also undo or redo the changes on our models. Last but not least, if we want to fetch our Pokemon, we can use simply a new macro called query. In SwiftUI, with this example, for example, we are fetching all the Pokemons in our database. This macro works very well with SwiftUI, but actually doesn't work with UIKit. So for UIKit, we will see another approach to fetch the data from SwiftData. Query, we can use query to specify different behavior. For example, if we want to sort our models by name, or if we want to specify a specific order. Or for example, we want to use different criteria to sort our models. We can define different sort descriptor that, and they use a keypath, so we can specify them. And we can filter our models with a predicate. In this example, I'm going to retrieve all the Pokemon that contains, for example, the fire type. With predicate, actually, we have some problems because they don't manage very well optional values. So if you have optional property in your models, there is sometimes some problems. And they don't manage enums. You can save an enum on your SwiftData database, but for example, the predicate won't use it as an enum, and to use a useful solution, for example, you can save the raw value of the enum and use a computed property to have the enum in that case. Okay, if we want to define a descriptor more complex, we can use FetchDescriptor. In this case, the FetchDescriptor class has this parameter as in its initializer, and we have to define more property after the initialization of the descriptor. For example, in this case, we are saying that we want only 10 elements to fetch. And we can pass this descriptor to our query macro. Okay, with UIKit, we cannot use the query macro, and we can use our fetch descriptor. So you can create some functions, and that function you can define your descriptors and use it on your model context and fetch your data. Okay, we are just at the end. We can wrap something up. So we have seen that SwiftData actually is very simple to use. Just with SwiftUI, we need 2 or 3 lines of code. It's simple to learn. And we can integrate it seamlessly with SwiftUI. Actually, I expect more in the future, because this is only the beginning for this framework. So I think that in the future we can do a lot more. But sometimes I thought that with models we can have some problems, because, for example, if we are working on a complex app, a very big app with different models, actually with SwiftData you can add the macro in the models. But we don't have, for example, a view like core data where we have all the relationship, all the models that actually we are using in our app. So if you can just lost your view on working on them. And actually, the feature that SwiftData has are less than, for example, core data. In our case, we cannot use complex predicate as, for example, compound predicate, and we cannot control the changes of our queries, for example, with fetched results controller that we can use on our core data stack. And there is also a terrible error handling because sometimes crash, there are some crash, or for example, for the option and the predicate, the error is not very clear, and you have to work on it and to search new way to go on. Okay, that's it. Thank you for the presentation. Just if you want to leave me a feedback, you can scan the QR code, and that's it.